All right, you ready to work through more subnetting problems? Oh, you see a problem? Good, because that's exactly the skill that you're going to need. By the time we're done here, we will work through additional examples of reverse engineering a subnet. It's kind of sad because I was like, what's a good creative way to start this video? And I was like, I'll stick a pen through my hair. And I used to be able to just kind of stick it through the wavy locks and it would just stay there. And now I just kind of have to balance it on my head. So let's go on to happier things. This is a typical what's wrong with this picture where things are obviously wrong with the IP addressing. Now, before we go through this and work through this side by side, I want to make sure that you know whether it's a corporate network, a home network, a certification exam, this is how most subnetting problems come at you. But it's not going to be this obvious. I mean, we're staring at it. We're like, okay, what's wrong with this picture? Obviously, it's going to be something with the IP addressing, right? Because that's the topic that we're talking about. In the real world, this will be one of 1,000 things it could be. Hey, his computer's not working. Is it powered on? Is it plugged in? Is the switch on the right VLAN? Is it Bob again? Bob always messes up his computer. Like, oftentimes the last thing you're thinking about is it the IP address? Is it in the right subnet? Is there something wrong with what we've done there? So just keep that in mind, is oftentimes these situations will come at you a lot twistier. But let's look at what we have. What is wrong with this picture? I know some of you are like, of course, the router's on fire. No, it's supposed to be symbolic representation, right? So that's not a problem. This is a router, and we remember, because we are superstars, that we have every single time we have an interface on a router, we have a network. So just looking at this design, that's not a problem. I mean, every single one of these interfaces represent a network that we're connected to. This one being the public internet, this one being a wireless network. Maybe they wanted to segment the wireless off into its own little bubble. And this being the corporate network. And you can see that we've subnetted, or we've done some subnetting around the network, different subnet masks, and we're getting complaints around the network, like things aren't working or whatever. So I guess let's just take it a step back. What's wrong with this picture? How would you go about this? Well, first and foremost, I would look at the router as the core, as in, the router should have the most reputable subnet assigned to it because it's the router, right? Either the router's going to be right and everything else is wrong, or the router's wrong and everything else is right. And so the router is usually what we're going to look at when we're trying to figure out, are these the right subnets? So this is a atypical case of reverse engineering the subnet mask. Okay, so how do we do it? Okay, well let's look. We've got 10.1.4.1 is the IP address /22, okay? So again, thinking about our 3 steps, converting to binary, we don't have to worry about that because it's already been done. They've given us the subnet mask. That's usually what we're trying to figure out in that step 2 of the 3-step process is, what's our subnet mask? Well, we have the subnet mask. So we kind of start from there and say, okay, well, if we have the subnet mask, which in decimal /22 is 255.255. What would that be? 252.0. We've got the subnet mask. We need to figure out what is the increment. So if I were to break a /22 into all binary, it would look like that. And I would take that lowest network bit, convert it back to a decimal number. So that'd be 124, right? So we're in the 3rd octet right here. This is where our subnetting magic would have happened when we originally broke these up. So I'll step back to where they must have began, 10.1.0.0, because again, we're incrementing in that 3rd octet. So we would have at some point done 10.1.4.0. I'm thinking ahead. 10.1.8.0. You could keep going down and down and down, but we've passed that router IP address. So we go, okay, what was the original subnet that this came from? Okay. I would say it's 10.1.4.0 through 10.1.7. I'm out of room. .255, right? If we were to squeeze that in there, I just can't quite fit it there. There we go. So okay, if that's the range, now let's look at this. Okay, well, that's got to be, you've got an iPhone right there with 192.168.6.0. Is that a problem? No, it's actually not. No, I know we're like, that goes against the grain of my decimal ways. Yeah, because in the decimal world, we're like, 0 is bad. That represents the network. But if we look at that, it comes from right in the middle of that range. Hang on, I'm gonna get my green pen out. So this is good. It's a good IP address. It just happens to look weird from our decimal mind. Okay, well, let's look at the laptop. 10.1.3.205. Seems that's a problem. Why is that a problem? Well, look at it. The routers in this subnet, 10.1.4.0 through 10.1.7.255, what subnet is that guy in? He's in the one above. Is his address valid? Well, absolutely his address is valid. It works just fine, but it's in the wrong subnet. We'll call that subnet 1. This is subnet 2. And remember, the whole purpose of a router is to move you between subnets. Like when you have a router interface, like I'm a router. There's my interface, right? I am a network. I am a subnet, right? So everybody that's attached to that interface better be in that same subnet or else something's very broken. And that's what we're seeing right here. This guy's got an arm. He's in the 10.1.4 subnet, and this guy's in a completely different subnet. He would need a router to move him from his subnet to this network. That's, again, I know some of you are like, I get it. Well, I've taught this enough to know a lot of people didn't. A lot of people are like, because so when you lay out all the subnets, again, you can get the process of subnetting down, but somehow miss the big picture. That's the big picture. Every one of these subnets represents a network that a router has to move you between. You can't have devices on different subnets coming into the same router interface, right? It just doesn't work. Let's look at this guy. Got another smartphone, obviously a non-iPhone. 10.1.5.255. Is that a problem? Well, I'm looking up there at that network range. No. Again, it repels our decimal ways of looking at subnet mask because we're so used to being like, 255, that's a broadcast, that's bad. Well, not when you apply this subnet mask. This subnet mask gives you a range of 10.1.4 through 10.1.7. Everything in the middle of that range is good. So this is good. This is good. This is broken. Now let's look at the other side of the network. We've got fast Ethernet 0/1 on that router on fire. It is 10.50.1.126. Okay, that's odd. Let's figure out, is that even a valid IP address? So we'll take that 10.1.50. 10. How about this? 50.1.126. And by the way, I do that so often, and I know a lot of people do as they're working with all these numbers. And if you're in an exam environment, because of that time pressure, it's easy to make a mistake like that, and it can really throw you off. So slow down. Just make sure. I'm talking to myself, not necessarily all of you. So /25. So we know a /24 is a class C, right? So this is the binary. So we'll just call that 24 ones dot 1, right? That's our 25th one in the 4th octet. So that'd be that, right? Good. So our increment when we first generated this network is 128. So at some point somebody would have said 10.50.1.0, 10.50.1.128.1. And it would be 256. So really there's only two subnets, 127, there we go, that you get for this. And I'm looking at that router and I'm like, okay, that's good. Is that a bad IP address? No, it's absolutely fine as long as all of these guys, the server here, desktop, as long as they all point to that as their default gateway, it is the last good IP address from that first range. That's a 2, by the way. So 10.50.1.0 through 127. 127 is the broadcast. 126 is just fine. Okay, so router configuration is good. Let's look at these guys. We've got this guy on 10.50.1.1. Now, again, we're so used to the decimal world and we're like, oh, well, that's usually the default gateway, isn't it? If we want it to be, but in this case, maybe we didn't. 10.50.1.1 can be assigned to the server as long as that server is configured to use the default gateway of 10.50.1.126. That'll work just fine. And all these guys are configured to use, .126 as a default gateway. It's very common to use either the first IP address of the subnet or the last IP address of the subnet as the default gateway. And then you just kind of use everything else before it or after it as the ones that you assign to your clients. Okay, so let's look at some of these other ones. Desktop PC, 10.50.1.125. 125/25. Yeah. I'd say that's fine, right? It's just the IP address before the default gateway. All good. How about this guy? 10.50.1.0. And burn. Immediately the alarms go off because I know this is a /25. So the .0 does represent the network. So that does not work. That is a fail because you can't assign the network ID of the network to a device. That belongs in a routing table. Look at this guy. Also wrong. Why? 10.50.1.160 is in this subnet. Same issue as this guy right over here. Do you get? Are you getting a good feeling about this? Does it start to make sense? Like settle in? I hope so. Because what was I going to say? Oh, that's right. Because if you're just looking at this and you're not thinking about reverse engineering, it looks fine. I mean, I'm looking at 10.50.1.160. Looks like a normal IP address. And the only way that you would know that it's broken or in the wrong subnet in this case, or a network ID or a broadcast. I mean, you'll see sometimes where somebody would say, "Hey, this is the 127 IP address," right? And it's like, you can't do that. That's the broadcast ID for the network. But the only way that you would know that is to do the reverse engineering of the subnet, right? That's why this is fun. It's just fun to do, right? So the last one that I would suggest. So what have we found? We found error, wrong subnet, error, network ID. So 3 things wrong. The only other thing that I would say is this guy. Router, just looking at the diagram, is connected to the internet, right? What is 172.20.1.5? I mean, first off, reverse engineering-wise, it's a valid IP address. There's nothing wrong with it. But it is a private IP address, right? The Class B range, 172.16.0.0 through 172.31.255.255, those are all the RFC 1918 private addresses, right? So when you're connecting to the internet, that will not work if you have a true public internet connection. And the only reason I kind of twitch a little bit when I do that is because I have seen in other countries outside of the United States, and I've seen even in the United States, in where my wife's family live, in Missouri, a little probably 1,000 person town. The ISP there hands out private IP addresses because in Bohunk Town, Missouri, nobody I shouldn't say that. Missouri's great. It's just humid. And so there's people, very few people in that small town that even would know or care what a public IP address is. So the ISP is like, well, why do we have to buy a whole bunch? Let's just NAT our clients, right? And very few people in my wife's town use the internet. Right. Good. So we have walked through. I know you're like, well, wait a sec. You just did one example. Actually, it's one example with a whole bunch of sub-examples, if you will. That's the idea. That's how reverse engineering subnetting works. And that's the style of troubleshooting that you're doing in that environment. I hope this has been informative for you. And I'd like to thank you for viewing.